Welcome back to 2021. Happy New Year, everybody. I hope you had a really great break. We are now starting Unit 6, which is called Bioenergetics, which is just a fancy way of saying energy in living things. Mainly, this unit is going to be about cellular respiration and photosynthesis, kind of those two main ways that living things get energy. But first, we're going to spend a few days just kind of introducing the idea of energy and making some connections and talking about how living things use energy. As I went through these slides, one thing that I did for this unit is you see up in the top corner, I marked on the slides which of them I did not print for you, just so you're not flipping through your packet looking for them. We are starting Unit 6, so you can grab your Unit 6 note packet as we get going here. And think about the role of energy in things like chemical reactions, molecular bonds, organelle functions, cellular work. These are all things that we're going to talk about as we go through this unit. As we talk about energy, energy can take lots of different forms. And this is something you probably already know. Energy can exist as light or heat. You can have chemical energy stored within molecular bonds, mechanical energy like the energy of movement, or electrical energy. So there can be lots of different types of forms that energy exists in. But regardless of the form, there are kind of two main states that we can have. You can have potential energy, which is a form of stored energy. That could be like gravitational potential energy when you're up high in the air. It could be potential energy stored if you compress a spring that holds potential energy. Or it could be chemical potential energy, like the energy stored in a bond within a molecule, or like we talked about in Unit 5, the energy created by creating a concentration gradient or an electrical gradient, a difference in charge. Those are also forms of potential or stored energy. You can also have kinetic energy, which is the energy of movement, and one of these can be converted into the other form. Photosynthesis is the process that first takes energy and makes it available to living things. So this, of course, is a transfer of energy where you take radiant energy in the form of light and transform it into chemical energy stored in the bonds of a carbohydrate. This is a really important process to living things. We will be looking at it in a lot more detail towards the end of this unit. But this is how energy first becomes available to living things. Living things can then take that energy and use it for all kinds of different things. They can use it for motion, for growth and reproduction. They can use it for things like sending an action potential. Remember, the energy stored across the gradient, that membrane potential across the membrane of a neuron, allows it to send that action potential and do that cellular work. It can be also used for things like bioluminescence, which is what you see kind of at the bottom right here. During chemical reactions, which is a lot of what we'll focus on in this unit, energy is transferred as chemical bonds are rearranged. That process is called metabolism. Metabolism is basically any chemical reaction that rearranges bonds. So it could either build, sorry, I can't spell, or it could break down molecules. We often think about breaking down molecules like digestion when we hear the word metabolism, but metabolism does also include chemical reactions that build molecules. One that you will hear a lot about in this unit that you may have heard about before are redox reactions, one type of chemical reactions. Redox stands for oxidation and reduction. In terms of biology, you don't need to know tons and tons about this. The important things to know about this is this right here. During a redox reaction, electrons are transferred, and anytime an electron moves, it carries energy with it. So throughout this unit, it's really, really important, this will come back over and over, that as electrons are transferred from one atom to another, they're transferring energy with them. When we talk about oxidation and reduction, this is how I remember it. If you remember that electrons have a negative charge, Reduced, it means that that atom or molecule, its charge has been reduced, which means it gains an electron or more. So it gains that electron, which has a negative charge, so it reduces the charge of that. Something that is oxidized loses or donates an electron. So when we're talking about redox reactions, sorry, that's supposed to be a negative sign. When we talk about redox reactions, we're really just talking about transferring electrons from certain atoms or molecules to others. But as we transfer those electrons, we are also transferring energy. And like I said, you will see that in both cellular respiration and photosynthesis. This is the main way that energy moves through those chemical reactions. So now you are going to spend some time thinking about energy and starting to get your brain back into school and dig into this a little bit. You have a packet that I sent home a while ago, and the first page says chemical reactions and energy. This is actually like a 4-page tutorial that walks you through some different things to get your brain thinking about energy in living things. For today, you should try and work at least halfway through it. So try to get through at least question 10. Do the best you can. You can look things up if you need to, but the point here is mainly just to talk through it with someone if you have someone available to work with, or think through it and see how far you can get. If you want to go a little farther than question 10, that's okay. We will be continuing this some more tomorrow, but tomorrow we will be talking about some of the topics in the second half of this tutorial. We'll talk about the laws of thermodynamics and a little bit about the idea of free energy. And so if you go further in this packet today, you may not totally understand what you're doing. So work at least through question 10. We will come back tomorrow to see how you did and continue talking about energy in living things. I hope you have a great rest of the day, and I will see you tomorrow.